My dear friends, welcome to Rajashekhar classes on applied data science with Python. This is lecture number 601. In this lecture, we will try to understand padding and strides. So now let's understand two concepts. The first one is called padding and second one is called strides. Just try to recall what is input image. This 6 by 6, this is input image, 6 by 6 image, and this is a Sobel kernel. On that what you are doing, on one thing that you have might noticed earlier in the previous lecture, what we were discussing, we had an input image whose size is 6 by 6, isn't it? What is our kernel size was 3 by 3 and our output matrix was 4 by 4. But what if I want my output matrix also to be 6 by 6, isn't it? What can I do? Because this input image of size 6 by 6, I don't want output image size to shrink. Actually, its output image size is shrinking. Why? Because your input image size is 6 by 6. Your output image, just see here, you are getting 4 by 4, isn't it? 4 by 4 means what's happening here? It is size. Here it is 6 by 6. Here output. This is output image, isn't it? It is shrinking. By doing some magic, if I want my output image, also, what is this? If I want my output image is same size as input image. What does it mean? Here in this context, in this particular example, your input image size is 6 by 6 but output image is 4 by 4. I need output image with 6 by 6. What can I do? Let's understand what happens when you do convolution. How does the size is reduced? So imagine we have n by n. Let me say we have an image. I don't want output image size to shrink, isn't it? Here it is shrinking. 6 by 6 is input image. My output image is shrinking to 4 by 4. I want input image size equal to output image size. That's I need, isn't it? Imagine we have n by n image, isn't it? And we have we convolve this with the k by k kernel, isn't it? So when you do convolution with k by k kernel, what happens is, just see, what is my n by n input image size, what is my kernel size, k by k. This n by n is the input size and k by k is the kernel size. That we have to understand. The output size that you get will be, what is the output size? N minus k plus 1 into n minus k plus 1. Just try to recall this example, previous lecture example, n equals 6. 6 by 6 input image, my kernel size is k by k, that is 3 by 3. In that case, n equals 6, k equal to 3. What is my n minus k plus 1? N means 6 minus k means 3. 6 minus 3 plus 1 equal to 4. Means my output size is 4 by 4. The output size is 4 by 4. This is very simple formula that we can easily derive, because both on horizontal, this is output size, both on horizontal and vertical axis, you can have you can only have n minus k plus 1. You can visually see it here. Just just try it with n equal to 8 and k equal to 3, isn't it? Just try just write it on piece of paper, and when you draw it on piece of paper, we will understand it much more easily. When n equal to 8 and k equal to 3, n minus k, what is n minus k is 8 minus 3, 5 plus 1. That is, you will get 6 by 6 matrix, isn't it? This is what you will get. What will you get? For n equal to 6, k equal to 3, you are getting 4 by 4, isn't it? For n equal to 8 and k equal to 3, you are getting 6 by 6. This is if you have not convinced the formula, please try it on piece of paper so that it will much more clearer for you. So now what do we want? We want 6 by 6 input. What is input? Input image size is 6 by 6, which means n equal to 6 is a kernel k cross k where k equal to 3. The output that I want here is 6 by 6. What output I need? I need output of size 6 by 6. I want, what is output? N minus k plus 1. N minus k plus 1 equals 6, isn't it? I have here is what is my n? N is 6, k means what? 3. N minus k plus 1 means what you will get? You will get 4, isn't it? But I want n minus k plus 1 is 6, but you are getting 4. What do we do? What do we do? You do simple trick called padding, isn't it? For getting same output image size. If you want to have output image size as 6 by 6, which is equal to input image size, what I need, a trick is called padding, and this is how this padding works. This is how padding works, isn't it? This is what is the input image size? Input image size is 6 by 6. What do we need? We need output image size is also 6 by 6. For this, there is a technique known as padding, isn't it? Imagine if n was 8. Let me assume n equal to 8 instead of n equal to 6. Imagine if n was 8, n equal to 8, what would happen? If n was 8, my n minus 1 k plus 1, that is 8 minus 3 plus 1 will be 6. So how do I convert this 6 by 6? Now I want to convert 6 by 6 matrix into 8 by 8 matrix. My input size matrix is 6 by 6. I would like to convert into 8 by 8 matrix, because if I convert from 6 by 6 to 8 by 8 by using this formula here, which is n minus k plus 1, I can get 6 by 6 output matrix the way I want. What do we do for that? We do something called padding. Padding is a very simple idea which says these are your, what is this, your input values. You have the input matrix, isn't it? 6 by 6 input matrix, isn't it? This 6 by 6. If I increase one more row here, if I increase one row at the top, just see, I am increasing one row at top. If I increase one row at the bottom, and if I increase one column on right, isn't it, and one column on left. Imagine if I do this, so I have padded, isn't it, the purple part, isn't it? Just see, the purple color, the purple part is called padding. The way you pad yourself when you go for tough sports like rugby, you pad yourself something extra. So just we are padding one extra layer around it. This padding is called padding by 1, because you are padding one extra layer around it. By providing it by one extra layer, you are changing matrix from 6 by 6 to 8 by 8 matrix. There is 6 by 6 matrix initially. We are converting it to 8 by 8 by padding, isn't it? There is one more column you are adding on left and on right, one more row on top and bottom, isn't it? So when I say padding by 1, you are padding it by 1, which means when you pad it by 1, the size of the matrix increases. So if you have a matrix of size n by n, and if you pad with p equal to 1, you will get, what will you get? Yes, this is padding by 1, isn't it? N by n matrix, your original matrix size is n by n matrix, what you are doing here, and if you pad it by with p equal to 1, you will get n plus 2 by n plus 2 matrix, isn't it? Okay, very simple concept. Now the question here is, what values will you keep in these extra cells, isn't it? The simplest concept is called zero padding. You just put zero values in these extra cells. We simply put zero values here, isn't it? Just we simply put zero values here. That's called zero padding. That's simply called zero padding. Zero padding can introduce some sort of error. I don't call it as error, some interesting effect. I can say it will create some interesting effects. For example, just say this one, zero padding. What is used of zero padding is used a lot. It is used, zero padding introduce some error. Zero padding used a lot in convolutional neural network. Zero padding is very simple concept. You basically pad one extra on the left, right, top and bottom and fill all the values with 0. This is one option that is extensively used in convolutional neural networks. There is a second operation in image processing where instead of padding it with zeros, you pad it with values see in the next pixel. Like for example, just say this one. For example, just here, which one is nearer to 0? Nearer to 0 is 255. 0 here. Just see here. Here I have 0 value, isn't it? Now I am, instead of keeping this one in this place, just I will replace 0 with this 255 like this, isn't it? That's what it says. 0 here, if I put 255 here, because the nearest pixel here is 255. Here also, if I put, I can put 255s like this, isn't it? If I put 255, if I place 255 and just see, I am placing 255 as this 0 is nearer to that 255 number. Just see here what's happening. Just observe carefully. Here I am filling this 0 with this 255. Why? Because this is nearer. This 0 with this 255. This which one is nearer? 255. This is nearer 255. 255. To all these zeros are filled with the nearest values. That's what it says. There is a question. What happens to this pixel? Just see this pixel. For this pixel, this is nearer, this is nearer, this is nearer, isn't it? What value should I fill here? Problem is, what type of value should I fill here? So there is a confusion, isn't it? In that case, what you have to do? Same value padding. You have to apply here same value padding, nearest row or nearest column replication. Here this is column padding, which is nearest for this one. This one nearest column is this one. Therefore what are you doing here? This is nearest column. This is a column. This is nearest column. Which one is nearer? This 0, isn't it? This is known as, what is this technique name? Same value padding. Same value padding is not used, if you speak strictly, same value padding is not used extensively in the whole of the convolutional neural networks, but can be used. Zero padding is much more simple. That's it. So by creating zero padding, I am able to simply create n by n matrix that I want. So let's go back to that case. By creating zero padding, I am able to simply create n by n matrix, output matrix, isn't it? I will get, for example, case 1. What is case 1? Your n by n is input image size, your convolution size is k by k. You will get n minus k plus 1 into n minus k plus 1, but I need output image size also n by n. So this is case 1. This is your simple convolution. What is my case 2? Case 2 is you have n by n matrix, you have k by k cross k kernel, and you have a padding p. Here we are newly introducing this concept, padding. In case 1, there is no padding. If you apply padding, if you have a padding p, value p, then what is the final resultant that you get? You will get n minus k plus 2p plus 1, n minus 2k plus 2p plus 1. If you observe carefully what's happening here, your n minus k plus 1 here, this also n minus k plus 1. Means here you are getting 2p extra. Here also you have n minus k plus 1, just see n minus k plus 1, you are getting 2p extra. That's important. That one must realize, this 2p. You are getting, which one is extra? This one is extra. If you compare with previous one, this is extra. This 2p. Here you don't have plus 2p, isn't it? Why is it so? Because your n has changed because of padding, isn't it? Your n has changed because of padding. Your n has changed to your n because of padding. Because of padding, this your n is converted into n plus 2p. Here also, because of padding, your n is converted to n plus 2p, isn't it? That's what it says. Just try, just see, your n is converted into n plus 2p. Here padding value is 1. For example, if I take my padding value is 1, because I am applying one additional column on left, one additional column on right, and one additional row on the top, one additional row on the bottom, isn't it? You are padding with 1. So when you pad with p equal to 1, in this case, the size of the matrix, the input image goes from your input image, it will goes from, what happens, just see, your input image goes from n to n plus 2p, isn't it? Because you are adding one at right, one at left, one at top, and one at the bottom, isn't it? Your minus k plus 1 had, just see, your minus k plus 1 is same just like earlier case, isn't it? Just see this one, your minus k, n minus k plus 1, n minus k plus 1. Here also you have n minus k plus 1. It's same. Your n has become n plus 2p. That's important. Your n has become n plus 2p. Your minus k plus 1 is in both the cases. Means case 1, case 2. That's because your n has transformed into n plus 2p. This is simple. We will see more cases. This is what padding does. Padding is very simple hack. Zero padding is something which is used extensively because you need output as exactly same size of the input image, whatever the kernel size is. And remember, your kernel can be 5 cross 5 also. It need not always 3 cross 3. Let's now forget that fact. Your kernel can be any size. They are typically square matrices and not necessarily always, but for most image processing kernels, they are square matrices. Just try to understand. For example, in this case, what's happening? Your n, if I say n equal to 6, this is 6 by 6 matrix. Your padding p equal to 1. Then what is output here? N minus k. N means what? 6 minus k. K means what here? K cross k. K means 3. 6 minus 3 plus 2p. Padding, your padding value p equal to 1. Therefore, 2 into 1 plus 1. What's happened? 6 minus 3, 3. 3 plus 2 plus 1. 5 plus 1, 6. You will get 6 by 6 matrix. Your input matrix size is 6 by 6. Your output matrix means by using padding, your input matrix 6 by 6. After padding it became 8 by 8, but originally it's 6 by 6. Your output also you are getting 6 by 6. That's the basic idea behind padding. I request you to go through this lecture once or twice. If you have any difficulty, please keep a comment. What we did here, by padding, you are equating, you are converting your 6 by 6 into 8 by 8 by padding, and you will get your 6 by 6 matrix. Means your input size 6 by 6, you are getting 6 by 6 output. Of course, your input image is converting 8 by 8 by after padding with p equal to 1. Just go through this lecture. If you have any difficulty, please keep a comment. Thank you very much. In my next lecture, we will try to understand strides.